Okay, in this video, we are looking at some basics in set theory. So, first let us look at the definitions of some words, basic vocabulary. That is, the first one is a set. A set is a collection of numbers or geometric figures or letters or other objects that have some characteristic in common. That is, in other words, a set is a well-defined collection of objects. Whatever you are representing here, it has some specific meaning, or they are all connected for that matter. In this particular example, I have A equal to 2, 4, 6, 8, 10, 12 and 14. We are seeing that they are all even numbers and they are less than or equal to 14. The maximum number is 14 here. So that's how it is defined in this case. So that's how a set you have. Another example, you can say a set B contains all the students of your class. So whoever is in your class, they all come in this set. Okay. Now, next thing is an element. Element is a member or an item of a set. So in this example, we had A equal to all the even numbers up to 14. So these all numbers like 2. 2 is an element of A. I can write 2 belongs to A. 6 belongs to A. 10 belongs to A. All these numbers, they are the members of the set A. That's why you can say it belongs to. And these are all called as the elements of the set. Now suppose if you have 9, is 9 an element of A? No, we don't see 9 here, so I'll write 9 does not belong to the set A. Right. Now the third word here I have subset. A subset is a set in which every element is also contained in a larger set. For example, let me take a set B. B contains, I'll write 4, then 8, 10. So B is a set whose elements are 4, 8, 10. And we are clearly seeing that all these three elements are also present in the set A. Therefore, we can conclude that B is a subset of A. That is, every element of B is also an element of A. Therefore, we say that B is a subset of A. Now let me take another set X. Let us say X has 1, 2, 3, 4. And is X a subset of A? No doubt, X has only 4 elements and A has more than 4 elements. But X has 2 elements which are not present in A. So I cannot conclude, or I can't say that X is a subset of A. It can't be a subset. Even though you have lesser number of elements, but we have to make sure that every element of this set is also an element of the bigger set. Alright, good. Now the next one is the universal set. The word itself indicates that universal set is a set containing all possible elements. Right. So it can also be called as a parent set, and we denote universal set by a letter U, capital U, or in some cases they denote by a letter mu. Alright. Now in this example, with reference to our set A, I can say that the universal set is 1, 2, 3, 4 all the way up to 15, because every element which is present in this set A is also present in the universal set. In fact, it contains all the elements that we are discussing in the particular scenario. Another example you can take, if A contains the students of your class. If A has the students of your class, then the universal set corresponding to this A is set of all the students of your school. Everybody in the school comes under the universal set, and A is the particular class out of the whole school. Alright. Now, lastly, I have here in this word empty set. What is an empty set? An empty set, it does not contain an element. So, in the set, it is defined in such a way that you don't have an element in this. Nothing, just empty space. Empty set, or sometimes you can call it as null set. Null set or void set also they say. So A has nothing in this. Example, you can take all the human beings whose weight is above 600 pounds. I don't think you have anybody whose weight is so high. So that is an empty set. Likewise, if you have no element, it is an empty set, and it is denoted by a symbol phi. Now, having known the basic vocabulary, now we can go ahead and do some operations among these sets. So before that, I need to know what a Venn diagram is. Venn diagram is a picture that illustrates the relationship between two or more sets. So now the first one here, this is the Venn diagram, of course. I already have it for you. Okay, the union of sets, the set of all elements that belong to at least one of the given two or more sets, and it is denoted by this letter U, a capital U, you can say. So the union between those two sets A and B is this whole shaded region. In this case, we have here set A contains horizontal lines, blue colored horizontal lines are your set A. Your A is those horizontal lines you have. That is the set A. And set B, you have all vertical lines. So this whole thing is set A and set B. Now an element for any number or whatever is the element that is contained in this set A or in set B, or if it is present in both A and B, can be categorized, or you can put it in the set A union B. So A union B in this case is the whole shaded area. The whole of the shaded area comes under A union B, whether it are horizontal lines or vertical lines, because union is that it contains everything. Okay, now what is intersection? Now intersection of sets, the set of all elements contained in all of the given sets. In this example, we have only two sets A and B. So only those elements which are present both in A and B, in the set A and set B. So we are observing that this particular region, this A whole space, which is common to both A and B, that is called as A intersection B. So in this case, you have all your blue lines and the red lines. That is the common area where you see the double shading, both horizontal and vertical, that comes under the common region, which is A intersection B. Now the third example definition, we have complement. Complement of a given set A, and it is denoted by a letter A and above that a line, small line you have to write, that is A complement, or you can also denote it as A with this symbol. It is the set of all elements that are not the members of A, right? A complement is the set of all elements which are not the members of A. How do you show this in the Venn diagram? It goes like this. A complement, let me put it this way, A complement equal to, leave this set A. Leaving this whole set A, everything outside A, this piece, all this area, including the set B, this piece, I have to just cover this one. Leaving this set A, everything comes under A complement. Mathematically, you can denote A complement as, I can write it as a formula, of course, U minus A. From the universal set, take away the set A, that gives you A complement. Now, the last thing is the difference between two sets A and B, denoted by A minus B, is the set of all the elements of A that are not present in B. Only those elements of A which are not present in B is the difference between A minus B. That is I have here A minus B equal to only horizontal lines. Only this is, that is, it should not be connected to the vertical, just this area. All this space, let me use this, only this space of A which is not connected to B. That's why it is called as A minus B. In the next slide, we are going to look at examples with numbers that will make this understanding much more clearer. What is A union B, A intersection B, A complement, and then A minus B, etc. Now, given universal set is 1, 2, 3 all the way up to 10, A is equal to 1, 2, 4, 7, 8, and B contains 2, 3, 5, 7, 10. We have to find A union B, A intersection B, A complement, and A minus B. Okay, first let us find A union B. Oops. A union B. In order to find the union between those two sets, right away I'll copy all the elements of A here. That is 1, 2, 4, 7, and 8. Union, I have 2, 3, 5, 7, and 10. These are the elements in set B. So after listing down the elements of A and the elements of B, in the next step, I'm going to bring down all these elements of A, that is 1, 2, 4, 7, and 8. Our aim is to find the union of those two sets. So it contains the elements of A as well as the elements of B. Therefore, now I'll copy the elements of B. So while bringing them down, I'll see if it is already listed here. If it is listed, I don't have to take it. If it is not, then you can copy it again. So 2 is the first element, which is already considered. So I don't have to write 2 again. What about 3? 3 is not there. Go ahead and write 3. 5, I have to bring down 5. Then 7. 7 is already there, so don't worry about it. 10, I have to bring down. That's all. These are the elements which are present either in A or in B or in both of them. So that is what is A union B. Further, I can write this in an increasing order. You can just leave it here, or if you want to make it look good, or in the right order if you want to write, I can put it as 1, 2, then this 3, then you write 4, afterwards 5, next comes 7, 8 and 10. I think I covered all of them. This is how you can write it to make it much more clearer to us. Okay. Now the second one is the intersection. How do you find the intersection between A and B? The second is A intersection B. When you want to find the intersection, the common between those two sets, once again, I list all my elements here. That is 1, 2, 4, 7, 8, intersection 2, 3, 5, 7, 10. I'm looking for the common elements between A and B. That's what is the intersection means. So it is, let me write down, 1 is here in the set A. Do you see 1 in the second set B? No, we don't. It is not there. So I cannot write 1 in the common part. What about 2? I'm seeing 2 here in the set A, and it is also there in set B. So I'll go ahead and write 2. What about 4? It is there in set A. You don't see it in set B. So don't write it down. 4 is gone. 7 is in set A, and you see it in set B also. So I'll write 7. That's all. That is the set A intersection B, which contains only 2, 7. Right? Now the third thing, we are looking for A minus B, or I think A complement. Okay. The third one is A complement. So A complement, by definition, all the elements of the universal set which are not present in A. So universal set, take away the set A. Now, what do you have in the universal set? It contains 1, 2, 3 all the way up to 10. I have to write those. And A contains 1, 2, 4, 7, 8. So let me write down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minus set A has what? 1, 2, 4, 7, 8. So 1, 2, 4, 7, 8. So when we subtract, we take only the elements of the first set which are not present in the second set. That's how the subtraction takes place. So 1 is there in the universal set and A. I'll cancel out that 1. And 2 is gone. 3, I can bring it down. 4 is gone. 5 is not there in second set. Write down 5. Then 6, I can copy. 7 and 7 gone. And I'll cancel up 8 and 8. Everything is gone. So 9 and 10. So this is your set A complement. So A complement has only those elements of the universal set which are not present in A, that is outside A, comes under A complement. Okay, now the fourth and last, let us look at A minus B. A minus B. All right. Okay, to find A minus B, we have to take only those elements of A which are not there in B. So 1 is present in A but not in B. I'll write down 1. 2 cancels out. 2 and 2 gone. And also 7 and 7. So you are left with 1, 4 and 8. That's all. This is your A minus B. Okay. Suppose if you want to find what is B minus A, we will write B first. That is 2, 3, 5, 7, 10 minus 1, 2, 4, 7, 8. That gives you, same way, cancel of the common elements, 2 and 2, 7 and 7 cancelled out. What is remaining? You got 3, 5 and 10. Okay, this is B minus A. So we can clearly see that A minus B is different from B minus A. Now this whole information you can also represent in the form of a Venn diagram. So let me quickly show you that. This is the universal set you have, which contains all the elements from 1 through 10, and this is set A. We have set A here and the other one is set B. Now we know that the common area you have only 2, 7. So I'll write 2 and 7 here. And in set, now this set A has 1, 2, 4, 7, 8. So out of 1, 2, 4, 7, 8, 2, this 2 and 7 are cancelled because you already considered now in the common area. Now what is left over? The remaining elements are 1, 4 and 8. So let me write down this 1, 4 and 8. We will write in the remaining part of the set A, only in this area, because 2, 7, this set B is overlapping there, so I should not take 1, 4, 8 anywhere this side, but outside that area, that is just in this, anywhere in this area, you will have your remaining elements of the set A, that is 1, 4 and 8. We copied there. Now go to set B. In set B, it is 2, 3, 5, 7, 10. Okay, so my elements are 2, 3, 5, 7 and 10. So out of those elements, this 2 and 7 are gone. Now we are left with only 3, 5 and 10. So let me write down 3, 5 and 10 in this remaining space. That is 3, 5 and 10. Now if you look at this whole set B, in this circle containing set B has the elements 2, 3, 5, 7, 10. Same thing, 2, 3, 5, 7, 10. That's all. So you got the set A and B, that is giving you A union B altogether. A union B contains 1, 2, 3, 4, 5, 7, 8, 10. This is 1, 2, 3, 4, 5, 7, 8 and 10. So from that universal set, we already have all these elements. Now what is left over? What is the remaining? If you cancel off all these, like 1, 2, 3, 4, 5, 7, 8, 10. 5, 7, 8 and 10. So only 6 and 9 are remaining from the universal set. So those remaining elements 6 and 9 you can write anywhere in the remaining space from the universal set. So don't touch AB, but you can write 6 here and 9 somewhere there. So that completes the Venn diagram. Now this Venn diagram gives you so much information. This 1, 4, 8 is your A minus B. 3, 5, 10 is a B minus A. 2, 7 is A intersection B. A complement also you had. A complement is what? Leaving the set A, remaining elements 3, 5, 6, 9, 10. So we can get a lot of information using this Venn diagram. Right? Okay, thank you. Thanks for watching.